In this video, I would like to discuss a way to manipulate concentration information, and that is doing dilution calculations. Dilution is something we do all the time. If you have ever made juice from concentrate, you've taken frozen juice and water and diluted it, that was chemistry. You probably didn't do a dilution calculation to get it perfect, but we will need to do that in lab to have control over our experiments. So a dilution is just the addition of more solvent to a solution. And this is going to have the impact of decreasing the concentration of that solute. The thing that's special about this is what does not change is the amount of solute. That ends up being constant throughout the entire process. And it allows us then to use this handy equation because if I take my concentration in moles per liter and I multiply this by a volume in liters, so these are the units, right? Units for volume and units for molarity. My liters would cancel and I'd be left with moles. So when I see C1V1 in my equation, this really equals moles. And because the number of moles of my solute is the same, no matter how much solvent I add, I can set this initial concentration times volume equal to my diluted concentration times volume, which makes these calculations pretty easy. The only trick to them is really identifying how much, like which is my first concentration volume versus my second concentration volume. So let's take a look at an example. So how much water must be added to a 50 milliliter 5 molar solution of sodium hydroxide to form 0.25 molar solution? I strongly recommend highlighting and pulling out the information that's presented in these problems because it's sometimes hard to keep them straight. So I know that I have a 5 molar solution of NaOH. And now I want to form a 0.25 molar solution. So this will be situation 1, my 5 molar, and I'm going to dilute it to form 0.25 molar. My concentration will decrease as I add more water. So I want to know how much water needs to be added. This 50 milliliters that I'm starting with, that's attached to my 5 molar sodium hydroxide. So my 50 milliliters is the volume that I have for my 5 molar. And I want to know what's the volume that I'm going to end up with. That total final volume will tell me how much I need to add to my 50 milliliters. So my 50 milliliters I can convert into liters to make my units match up nicely. You don't have to do this because you'll get the same units on either side, but it's helpful. 1 liter divided by 1,000 milliliters. This is really 0.05 liters. So let's set this up. C1V1 equals C2V2, where C is concentration. So initially I have a concentration of 5 molar. And I have a volume of 0.05 liters. Now I'm going to add water until I'm at a new concentration of 0.25 molar. And I don't know what my volume will be. That's what I need to find out. So I'm going to divide both sides by 0.25 to isolate my volume. So that volume 2 equals 5 molar times 0.05 liters divided by 0.25 molar, which will equal 1. This equals 1 liter. So this is my final volume, but my starting volume was this 50 milliliters. So this is my starting volume. And the question is asking what is the water that needs to be added. So I need to add water until I have a volume of 1 liter. So the water that I'll add will
be that 1 liter minus what I already have, which is my 0.05 liters. So that's my equal point.